We're going to start getting into some actual machine learning now, starting with an introduction to random forest. Once I introduce random forest from a conceptual level, we'll jump into fitting and evaluating our own random forest model in the next lesson. I want to first note that random forest is one type of a machine learning algorithm that falls into a broader category of ensemble learners. This takes advantage of the ensemble method, which is a technique that creates multiple models and then combines them to produce better results than any of the single models individually. The idea behind ensemble learning is that you can combine a lot of weak models to create a single strong model. The basic idea is that this leverages the aggregate opinion of many over the isolated opinion of one. This method has a very strong theoretical motivation. With that said, we're not going to get into those details in this course, but it's just one of the many reasons that ensemble learning is a very popular method in machine learning. With that context, let's jump into defining random forest. Random forest is an ensemble learning method that constructs a collection of decision trees and then aggregates the predictions of each tree to determine the final prediction. So in this case, your weak models are the individual decision trees, and then those are combined into the strong model that is the aggregated random forest model. So you may say, I want to build a random forest model to predict ham or spam. Let's just say that the random forest has 100 decision trees in it. Then each of the 100 decision trees are built independently of one another, and each will output a prediction of either spam or ham. So let's say 60 of those decision trees vote spam and 40 vote ham. Then the final prediction of the random forest model will be spam. So it's really just a simple voting method for the trees. There are a lot of benefits to using random forest. It's a very versatile and powerful machine learning algorithm. For one, it can be used for classification or regression, so that means a categorical response or a continuous response. It easily handles outliers, missing values, skewed data. The data doesn't even have to be on the same scale. It accepts various types of inputs as well, maybe ordinal or continuous data. It's also less likely to overfit than some of the other machine learning models. We'll get more into that topic later on. And it generates feature importance score for each feature. So random forest is really versatile, and it often makes a terrific first pass at your data because you rarely have to do a lot of data cleaning, because it can accept pretty much anything. Beyond that, it's powerful, and it outputs feature importance to help you get a feel for which of your features are really useful and which aren't. So this is an extremely high-level introduction to random forest, giving us just enough information to understand what we're actually doing when we implement this in the code in the next section.